Okay, so hopefully we remember from last week that we looked at, the thing we looked at, remember, was labelling triangles. So remember, if we had, and who can remind us of this, if we had a triangle and we had this angle here that was like, let's say 30 degrees, what do we label that side as?
Isn't it the opposite?
The opposite. What was this one labelled as?
The
hypotenuse, or H hypotenuse, and good.
Oh my god, yes.
Good. Okay, so guys, the reason we do that, so we can go back over here, Sigrid, the reason we do that is that we have these things called similar triangles in maths. And the idea of similar triangles are triangles, they're not necessarily the same size, not necessarily the same size, but the same shape. So you might have, for example, and a simple example of that is like if you look at A4 like paper, A4, A3 paper, they're all the same shape but just different sizes, aren't they? Yeah. And the idea of that is that the thing that's used that we can use for that is that the ratio of all the side lengths is the same. So if you look at all these triangles here that I've drawn up, these are all similar triangles of different sizes, but it's supposed to be cos 60 equals a third, it's half, sorry. What we have here is that these all have the same ratio between this length and this length. What is that ratio, by the way, in this case? So what's the ratio between, in this case, the adjacent and the hypotenuse? Like, how many times bigger is that one than that one? It's twice as big. So that means for any and so if you guys I won't get you doing it now, but if you get your calculators out and type in cos of 60, which is a half, that's actually telling you that the adjacent over the hypotenuse ratio is a half, so that's always going to be double that. And that would be regardless of what size the triangle was. So if that was 8, we know this would have to be double 16, 5 would be double 10. So regardless of what they are, so if we were given one of those lengths, we could be able to work out what the other one was, couldn't we? So that's kind of what this is all. So all this stuff with when we're doing trigonometry is all about ratios. And these here are the 3 ratios that you need to know. And they're to do with so these are all the ratios to do with the 3 different pairs of side lengths we can get. So the ratio for any angle, the ratio of opposite over hypotenuse is what we call the sine ratio. The ratio of adjacent over hypotenuse is called the cos ratio, and the ratio of the opposite over the adjacent is we call the tan ratio. So those 3 buttons on your calculator, that's what they refer to. So if you were to type in, for example, cos of 60, that ratio would give you a ratio of a half, and that's why we know that means that adjacent has to be half of the hypotenuse. That's what it means. So it actually gives you like a ratio like that. So we can go over we've got a couple of examples of how we can use this over on this side, Sigrid. So this one here, pretty simple question here. We want to find, so we got this angle here. We want to find what the tan ratio is. So if we were to label this triangle, what's that length? That's the opposite of the angle. So that's the opposite. That's the hypotenuse, and this is the adjacent, isn't it? So what is the tan? So what's the tan ratio in this case? Or the tan ratio is what?
15 over
opposite
20
over adjacent, 15 over 20, or we can simplify that ratio down to like just 3/4, can't we? So that means whenever and we don't know what that angle is, but that means that any triangle that's similar to that would have a ratio of the opposite, so that opposite over to the adjacent would be 3/4. So that's what we mean by them being similar. This one here, this one's sort of asked a bit differently. If we knew that the sine ratio was a third, so if the sine ratio is a third, what is that actually telling us if we know? Yeah, so if the sine ratio is a third, it's telling us that which one is a third of the other one. If the sine ratio is a third, the opposite is a third of this one. Can we see that? Because opposite over hypotenuse is a third, so that means the opposite always has to be a third. So in this case, you could write you could say that 1/3 equals x over 24. You could write it like an equation if we wanted to. That would be one way we could do it. So we know that the ratio has to be a third. So we can say, okay, that over that has to be equal to a third, and then we can just solve it and say therefore x equals
8 over 24.
X equals 24 over 3, which is 8. So for that triangle to be in the ratio 1/3, x has to be 8, doesn't it? That's the easiest way to work it out. You don't necessarily have to do it like that, but that's how I would probably suggest you do it. This question here looks at kind of links into that video I showed you guys at the end of last week as well. So I'll just write this off so I don't get it mixed up. So imagine you have a staircase. So there's a lot of practical applications to this kind of thing too. Imagine you had a staircase, and we knew the staircase had an angle of inclination of 30 degrees. So if you measure that, you walk up an angle of 30 degrees, and the length of the staircase is 6 meters. How high up? And we also know the sine ratio, and this is one of those other ones. If you're going to remember any ratio, and if you actually just remember any of these, the best one to remember is the sine 30 is a half. So if you have an angle of 30 degrees, the ratio of this length to that length is a half. That's a really good one just to remember because that comes up a lot. It's like remembering in Pythagoras, you know, the 3, 4, 5 triangles. And we know that that's it. The best one of these, the equivalent of trig ratio to remember that's really useful is sine 30 equals a half. And that's why that video, and that's the video I showed you on the Big Bang last week was related to that too. So we could just say a half equals, and this would be like an unknown here, would be the x length. So a half equals x over 6. So that has to be half of that. I mean, hopefully we can just see it's 3, but sometimes it's not going to be whole numbers. Then we just say x equals 6 on 2 or 3. So the opposite. So the answer to that would be 6 meters. So we should put units in these ones as well. Actually, shouldn't have we should be 8 centimeters. So just we're going to obviously learn as we go on with this, and this will be next lesson's goal as well. Actually, Sigrid can probably turn off now.